Hi, class. Let's start the chapter, please. Well, in this chapter, we'll talk about services. We did talk about production. Now we're talking about services, which, as we said, it's a different because of being tangible products. Now, so service process. We will be learning about understanding the characteristics of service process, analyzing simple service systems, understanding waiting line or queuing analysis, because this is the most important part of a service processes, is like the warehousing of services. So service package, for every service has a service package, a bundle of good and service that is provided in some environment. We said in the way early, there is product and service behind it, and there is service and product behind it, and there's a pure services. And we mentioned the fact that, you know, product like a goods that you see it in, for example, Dollarama, no service behind it, and then you get a product that's a service behind it, like a mobile, and then you got the IBM, for example, which is a service, a product behind it, and a service, pure service, talking about um, teaching, like a lot of colleges, doctors, and lawyers. Now, the bundle consists usually of 5 things: supporting facilities, facilitating goods, information, explicit services, and implicit services. Supporting facilities like the physical resources that must be in a place before a service can be offered. Anything that should be there, like, you know, an office, a place for examining patient. These are the physical resources that must be in place before a service can be offered. Facilitating goods, the material purchased or consumed by the buyer or the item provided to the customer. So it's like, you know, facilitating goods is like the mobile. When you go and take the service of a telco company, you buy a mobile there from them, and this is a goods that called facilitating goods. And then you get the information, which is the operation data or information that provided by the customer, enable efficient and customized services. So if there is, you know, some customization, some requirement by the customers, provided by customer to enable the efficient services and customized services. Like, you know, you like to have a maximum $100 long distance. Explicit services, the benefit that are readily observable and which makes up essential features of the services. You buying a mobile services, definitely you can make phone calls. So that's an explicit services. And the implicit services, the psychological benefit or other extensive feature that service like a prestige, privacies, and so on. So the prestige is like you're buying, you're getting an iPhone 10 or 11 or 12. This is like a something prestige from Bell, for example. Now, things that the operation classification of services, service organization are classified according to the customer they service and the service they provide to the customers. So what kind of customers is there and what kind of service they provided. And classification like type of your customer contacts, what kind of contacts that you have. A creation of services, what kind of service you VIP, non-VIP, regular, all these things. The physical presence of the customer in the system, whether they are there coming to see you or they're on online or they make their request and waiting for the response and all these things. The service system with the high degree of customer contact, usually it is are more difficult to control because suddenly if you have a 20 people coming in your small store and requesting a service is different than one person shows up. And the work process involved in providing the service itself, like in the legal or the medicine hospitals, the work process is different than in fixing the car. They're totally different. So that's also affect the service packages that you are providing for them. Now, the service organization design. How we gonna design the service organization? According to what? Service, cannot be stored in the inventory. So as we said in the beginning, it's a perishable good. In service, usually the capacity is the dominant issue. So you cannot, have something in the warehouse. The capacity, if you have one person can deliver service for 10 people, if you have 2% can deliver service for 20 people and so on. So the capacity. Now, when you have too much capacity generated excessive cost, and for example, if you have 10 people wait there, provide service and every an hour, somebody shows up and takes 5 minutes, then this is an excessive cost. And on other hand, insufficient capacity leads to customer loss. If you have one person and there is 10 customer comes in every 5 minutes on a reverse side, that you will end up losing the customer. Losing the customer, there is other loss in them, like a word of mouth. They say they don't provide good services, all these things, so people would not come in, and you lose more businesses. So seeking the assistance of marketing to influence the demand. In providing services, marketing is very important where they can, influence the services required. The other thing is waiting line models provide a powerful mathematical tool for analyzing many common service situations. You waiting in line, this is something is a very scientifically driven and can help you as a service provider to manage your delivering of services. So there is a whole chapter about waiting in line. So what kind of services? The service systems that we have is basically it depends of whether you have a high sales opportunity or degree of customer service contacts. These are the things that you look at it. And it's, if you look at it, for example, there is a mail contact where you sales opportunity is really low and the customer service contact is low. On the other hand, so you have a buffered core. You don't need that anymore. But permeable systems is when there is like a phone contact, face-to-face, tight spec, is that there is a chance of sales opportunity mediocre, is not a low, and you see the customer service is kind of in the middle. But then you have the extreme one where the sales opportunity is very high and reactive. Customers usually uh, according to your active, it will be a reactive. You respond to its request according to it. And this is where you can have a high sales opportunity. And these are how you categorize them. Because here, what you're going to do when you categorize them according to this, then you know where is your sales is happening, and you need to deliver sales. And at the same time, you need to deliver good services, and you need to balance these two together in order to get an efficient services. Now, this is another way of looking at it. For example, processing mail at the U.S. Postal Services, it is a clerical skills, paper handling, and office automation. But then you got the phone, you need the software support service, troubleshooting, and because the phone is there is a verbal skills, scripting, and computer database. On the other hand, for example, in the accounting, certified accounting or doctors face to face, it has to be customized, and you need to talk to the client, see what they're looking for, and you provide them the service they're looking for. Now, there is other services available in the market, which is what you have is called when you create a web platform. That is, there is three part, whereas one is like a web platform business, a company that creates values by enabling and exchange information between two or more independent group, like YouTube, like eBay's, and all these things. So here, where they say platform service business provider platforms is the transition provider. So if there is a customer talking to the customers, is a different, and this process is happening in a different way. Now, there is, when you create a services, there is before that, there is a service blueprint, is the flow chart of how the service is happening, and where is the things might go wrong, which is, and what's supposed to do if this goes wrong, which is called a failed saving. So the standard tool for the service process design in a flow chart, which is called a blueprint. So in the flow charts, how the services is moving. A unique feature of the service blueprint is the distinction made between a high customer contact aspect of the service and those activities that the customer does not see. So when you do a blueprint, basically what you do, you show the services that is provided, but there is so much things happening behind the scene that you need to connect in that blueprint and see the whole picture of how these things is happening. Where the customers usually don't see, they see the front services, they don't see the back services that is happening, such as delivering product on time, making orders, all these things on time, bringing things from warehouse, if it's near to you, to the back office, and where the service provider comes and bring it for you. And all these things, this is a blueprint, the flow chart, how this thing is happening. And the fail saving, we said, as you know, um, involves using a service blueprint to identify the opportunity of failing. It's like a disaster recovery in a way, but situational, and then establishing a procedure to prevent these mistakes from becoming defect, which is called Opoka Yoke's Japanese way of doing it. So Poka-yoke is a procedure that block the inevitable mistakes from becoming a service defect. Avoid mistakes. It's basically you avoiding the mistakes. It is procedures how you minimize you're avoiding mistakes. So many applications of PokeYux to the services, warning methods, steps to lead to a mistake trigger. There is something saying if things is happening up to this level, there is some mistake is gonna happen. It's like a benchmarking things. Could be physical or visual contact method. So the three ways of doing it without going into details is called the 3T: task to be done, treatment accorded to the customer, and tangible features of the services. These are the 3Ts of PokeYo. Now comes in the issues of waiting line problem or queues. Excuse me. A central problem in many service settings is the management of waiting problem. We need to minimize the waiting overall and also minimize in the same time service providers, because the more service providers means more cost. But in the same time, if you're not providing service on time, that probably will make you lose sales. So reducing waiting time costs money, but raise customer satisfaction and through and then more generating. So it is two things that you need to balancing. If the customer doesn't wait that long, it's going to come again and make request more services, which is good for you, and also will tell his friends, which is good. So this is very good. But to deliver these services, you need more people to deliver the services, but you want to make sure that you exactly putting the right numbers to provide these uh, services. Now, on the other hand, to cut the cost, there is other ways of doing it to make people wait more, but with more patience. When people waiting are employees, it's easy to value their time. When people waiting are customer, it is more difficult to evaluate their time. So if the employees, you know, um, your co-worker is waiting, you value his time, you're trying to provide him the services, but if the person is waiting is your customer, you have people to have a tendency not to value their time, and this is what makes you lose sales. So providing services to the customer is more important than employees because you don't want to lose sales in it. So that's the issues there. Now, I think some of you guys have seen this in Google, and it shows that when is the peak time. If you check on the Google, it shows you the peak time of you need to avoid, or you need to make sure that not to go there because the service is too many people and there is a low times, and this is daily. You can see it in probably for lots of businesses. But the whole goals comes in from the arrival, the number of arrival. Arrival often vary greatly on the time. You see people in the big stores, they have some counting thing and they're counting people who's coming in and going out and how long they're staying. So what time they are arrivals in the timing, and it tells you the numbers of the people. But you notice that the capacity is a standard. So sometimes during the daytime, a customer have to wait longer, sometimes have to wait less, but you want to make sure that your capacity should, if it's a flexible, meet this changing time. Most of the time, it will be difficult to match it 100%, but without increasing your cost. So, excuse me, managing quiz. First, you need to segment the customers, and then train your servers, people who provide service, to be friendly. Um, Inform your customers of what to expect, and try to divert the customer attention when you're waiting, playing a music, having a video, having a, especially if you sometimes you walk in some restaurants, you find TVs, that makes you wait more, or and also encourage the customer to come during the lower time. So these are the things that you need to look at it. So what kind of customers, you segment them, you train your servers to be friendly. But now there is a third thing comes in the picture, which is now you notice that the COVID has also affected the waiting, the queuing systems also. So this is how it looks like, customer arrival, and there is a probably ticket counters and customer exist. You see, and this is the service. Later on, we'll be talking about different kind of service provider. You can distinguish between, for example, in the movie theaters, how you provide, tickets versus the train versus the buses versus where is the, uh, there is a football or a hockey. These are different type of people, segmenting them different, timing of providing the service is different, the peak time is different, the waiting line is different. These are all things you need to take into consideration. So you want to know how many customers arrive and how many customers at a certain time are provided services. And you need to also to consider this people who wait in a line and after a while they just leave. They don't want to get your service because they don't have time. Sometimes during the lunch hours, for example, you look at it and you see, for example, suddenly gets busy because during the work hours, people cannot go and get their services during the lunch hour. They might go and get their services done in other places. So how you look at the queuing system analysis, there is two-way population sources. There is finite and infinite. For example, in the finite is like the oil when they used to change the service of the oils. There is certain amount of cars can be waiting for them, but in a football arena, they could be open for a big numbers. Or if you're providing, in a mall, there's also can be an infinite number. But the whole thing is the customer population, who are your customer from all these people that they coming in, who is your customers. The population size could be finite or infinite, like we said, like the one in a mall, it could be infinite, and there's everybody is coming in the mall, you don't know which one is going to be coming to you and wait in a lineup. So how do the customer arrive at the system is a very important. Customer arrival rate or customer arrival rate that expected the number of the customer that arrived during the each period. You might have to look at it like sometimes the customer comes in and they're very steady, one person every 10 minutes. Sometimes you have a sudden boom. They come in certain hours. Sometimes they come 10 by 10 or 100 by 100. These are all things that you need to take into consideration while you're doing the queuing thing and providing services. So the customer arrival characteristics is basically you have the distribution, you look at it, you look at the pattern, how is this happening, and you look at the size of arrival, and you look at the degree of patient how long they can wait. And then according with when you look at the distribution, whether you have a constant or you have suddenly exposed or you have a combination, then in the pattern whether it is controllable, the arrivals, or uncontrollable. Size of the arrival could be single, could be multiple people, 10, 10 or 100, 100, and how long they can wait to be in line. The one is patient can wait and patient, there's two type, arrive, view, and leave, and then they arrive, wait a while, then leave. These are two type of the people, so what's the big deal about it? If somebody comes in and arrive and wait and leave, that makes the line is bigger, longer. People comes in. There's also people will come and see the line is so big, and they also leave, just like what they do. So these are things that when you providing a queuing, you need to look at them. Now, length of line, how long is the line? Sometimes, as we said, infinity potential length, as long as you can. And there is a limited where it's, they're changing the oil in the Mr. Loop or something. You cannot have more than 4 or 5 cars waiting. And then you have the single line, which is one line goes straight, like what's happening now in COVID. But in the old days, every cashier in the supermarket has his own line. So then there is a single line and there is a multiple line. And there is also, as we said, a queuing discipline, how you doing it, first come, first serve, or short processing time, who have small things. As you see it also again in supermarket, there is if you have less than 10 items, there's a short processing. Um, it can be done by reservation, which is in the restaurants or emergencies. That makes a big deal in the hospitals. So that's also affect the number that they utilize people. Why we need to know these things? Because if somebody in the hospital, you cannot perform these people at 100% of their capacity. They should be, because it's an emergency type, but, especially in the emergency section. And also in the fire department, you wonder always, most of the time they're sitting doing nothing, but actually because sometimes they need to be free. Anytime there is a fire, they can go and attend it and make sure that the problems. So the emergency is also, you need to look at it, and limited needs, whether somebody needs a small things to be done. So it does affect the line. You cannot have many times you go through this experience that you feel that somebody in front of you is the bank, for example, and you have some money you want to deposit or withdraw or a small thing, but if somebody is in the front of you, you feel like he's getting a mortgage for his house. It takes forever, and you become very impatient. Thanks for mobiles and TVs and all these things slow you down, but you need to distinguish these things between each other. Now, queuing system factors is the length we talked about it of queuing, how much waiting room space is available, number of lines, how many servers are working. So if you have 1 or 5 servers or 10, QE displaying, how do new arrivals enter the line? How do you decide which customer you serve first? First come, first serve, emergencies, like the ones in the hospitals, something like that. And we talked about the service time distribution. So what is the service rate and how much does it vary? So the service time distribution is about a time that customer or unit spent with a server once the service has started. So it's basically the service rate, the number of the customer or server can handle during this 1 hour or 2 hour or this period of time, how many can handle. Now, could be a constant. Each service takes the same time, like 10 minutes, 10 minutes are easy to calculate. Or it could be like a car wash machine, or could be a variable. Each time it takes random. Services provided by humans, like legals or doctors, or can be customized to individual customers. And this is could be a variable from half an hour to 5, 6 hours. You don't know how long it takes. So you need to take it to this consideration when you do a service timing. So we said there is the channel itself, the lineup structures is there is what you call a single channel and single phase, like this one, a single channel, single phase, and this is what's happening now in the um, any stores, coffee shops, for example, single with a one cash machine, single channel, multiple phase when you have each cash register, two people or three people is waiting, and you can see in the exhibit that you need to distinguish between single channel, single phase, single channel, and multiple phases. You can bring lots of examples. Just use your imagination. Multiple channels and single phase. You have, it's look like that. So multiple channel and single phase. When you go and you say um, five cash registers and five people spread it there, and they go in, and then you have multiple channel, five cash registers, but there is people are waiting in it. You need to look at also the mix of these things. Could be a multiple, as we said, multiple channel, multiple phase, and multiple channel, multiple phases. And when you have the mix of that, so it is a combination of how you're going to work it out, the timing and the service that you're going to provide, utilizing all these options that if they are available for you. I hope now you understand how the queuing is works. A friend of mine, I think he's from Pakistan, he created only a queuing system. We also worked on it in Iran. He did it for IBM India, Pakistan. And it is on your mobile. You book your appointment with the banker, saved so much time and lots of places, for the bankers not to operate because they know where the peak time and the customers comes in on the time. And instead of going inside the bank and pick a number before you go home, you go there to home. It's happening in the hairdressers also. You just book your time while you're there. You can get the service right away. So the customer who have been served have two exit fate. Low probabilities, low chance of they can come back again in the same time and get that services, or they might have probability that they return to the same thing. And you need also to distinguish that, because you don't want the customer, if he comes in out of the lineup and get the service, do you want him to come back in the same line again waiting, or he continue coming in the front? These are the things that you need to take also into consideration. So this is the end of the chapter. I hope you guys, ready for the comment that I'm going to make if I have time. Bye bye.